What is going on, guys? Welcome to this video. Chances are you are in quarantine right now, and the reason for that is the coronavirus, the COVID-19 virus. And in this video, I want to talk a little bit about this virus, but not really from a societal perspective or from a medical perspective or from a political perspective, but from a mathematical and programming perspective. So we're going to talk about how to analyze the COVID-19 virus in Python, how we can use libraries like NumPy, Pandas, and Matplotlib to get a statistical analysis of this virus, how it spreads, what's the mortality rate, the growth rate, and so on. So this is what this video is about. We're going to visualize the individual things in graphs like this one. So this would be the total confirmed cases of COVID-19 all over the world. So we have Austria, Italy, US, Spain, France, Germany, India, and we could add more countries if we would like to do that. So this is what we're going to do in today's video. So let us get into the code. Now, of course, before we can get into our analysis, what we need is some data. We need some data from the internet, and one of my favorite pages right now is worldometers.info/coronavirus. I mean, favorite is probably a bad word for this, but here you can see the most current data. It's always updated, almost always updated, where you can see how many cases we have, how many deaths we have, how many recovered cases we have. The problem with this page, however, is that it does not offer any CSV or XML or JSON files. We basically just have this and have to work with it. So of course we could do some web scraping with the BS4 library and extract the information here. But instead of doing that, I found another page, which is this one here, which is hum data or hume data, I don't know. And it basically has some coronavirus data in the format of CSV files. So we have the confirmed cases, we have the deaths, and we have the recovered cases in CSV files here. So you just have to download them, and that's it. I've done this already, and I have them on my desktop. So let's take a look into them and see what they look like. As you can see here, we have the province or the state. Here we have the country or the region. Then we have some coordinates with latitude and longitude. And then we already have, it's not easy to see right now, but then we have the dates here and the number of total confirmed cases. So this would mean that at the 22nd of January 2020, this country had 2 cases, then 3 cases, 5, 7, and so on. And this goes all the way up until yesterday. So today is the 23rd, and it goes up until the 22nd. So tomorrow it will probably also include today. So you have to update this file, or actually you could also just download it into Python directly if you want. But when you have this file right now, what you do is you go ahead, copy all of these files, or actually not copy, but move them and put them into the directory of your Python file. And then you can just rename them because the names are pretty long. So you could just say COVID-19 underline confirmed .csv, and this would be the deaths. So we could say COVID-19 deaths.csv, and then we have COVID-19 underline recovered.csv. And this is how you get the files themselves, so how you get the data. And now we're going to talk about how to get this data into our script. Now, before we can actually start doing anything with this data, we need to import a couple of libraries. And the most important library of today is Pandas. We're going to give it an alias of PD. And also we're going to import matplotlib.pyplot as PLT. These two libraries are data science libraries. If you don't know them, check out my data science tutorial series. There I teach you how to use them basically. So these two libraries are what we're going to need today. And the first step right now is to import the basic CSV files into our script as data frames. So we're going to say confirmed equals pd.read CSV. And we're going to pass COVID-19 underline confirmed for confirmed cases. And then we're going to do the same thing with the deaths and the recovery. So we're going to say deaths and recovered. And of course, we have to change it here. Oh, I forgot the CSV, sorry. COVID-19 underline deaths dot CSV and COVID-19 underline recovered dot CSV. So these are the three files and they're now in our script, but we cannot really work with them yet because they don't have the format that we need. Because if I go ahead and print confirmed, for example, you will see that the structure is not really optimal for calculations. Oh, this was an old script, sorry. There you go. So basically, you can see that we have a province, a state with a lot of not numbers with some random index here. Then we have the country and the region, or the region. Then we have the latitude, the longitude, and then we have all the dates. Now, what I want to have here in order to work with this data as efficiently as possible is I am not interested in the province or the state. So what I'm going to do is I'm just going to drop that column. And also I'm going to aggregate to combine all the individual country entries. So for example, if I have a lot of entries for the US, for the United States, I have New York, I have California, I have all these individual things. I'm going to sum them up into one entry, which is US. So I have one row for the US data, one row for the China data, for Japan, for all the individual countries, but I'm not going to split it further up into provinces and states. Also, we're going to drop the coordinates because we're not really interested in them. I mean, they might be interesting depending on what you're trying to implement here, but for our statistic analysis, it's not really important, so we're going to drop these columns. So the first thing that we're going to do is we're going to say confirmed equals confirmed dot drop. This is the function we're going to use in order to drop this. And what we need to do is we just need to specify the column name. So we're going to say drop province, state, and lat, and I think the other one was long. And we need to specify axis equals 1. So then we can go ahead and see if this worked. And as you can see, we now have the country, the region, whatever, and we have all the dates. Now, the next step is to somehow aggregate these values, because as I said, we have a lot of US entries right now, duplicate entries. Actually, they're not duplicate, they're just the same country, but they have different numbers. So we need one entry for the US. So what we need to do is we need to group by country. So we're going to say confirmed equals confirmed dot group by. And in this group by method, I'm going to pass confirmed, and I'm going to pass the country region column, sorry. And we're going to use the aggregate function here. So what we're doing here is we're grouping by the country and the region, and the result shall be aggregated. So we're going to say aggregate, and what aggregation are we going to apply? We're going to sum them up. There are also other aggregations, but in this case, we're interested in the sum. And this is what we're going to do for all the things that we just imported. So we're going to do the same thing for the deaths. We're going to do the same thing for the recovered. And let's just not make any mistakes here because that would be stupid. Should be fine. And then we do the same thing here again. So we're saying deaths and, oh, actually confirmed was the first one, sorry. Second one, deaths, recovered, deaths, recovered, and don't forget this one here, deaths and recovered. There you go, we can now print it, and one last thing needs to be done. I mean, actually it doesn't need to be done, but it's the way I prefer it, because now what we have is we have the countries here as the key, and then we have the dates, the individual dates as the features, or actually both are the keys, and the number then is the feature, but I would like to transpose this and have it the other way around. So the rows shall be the dates and the column shall be the individual country. So what I'm going to do is I'm going to say confirmed equals confirmed dot t, which is which returns a transposed version of this data frame. So deaths equals deaths dot t, and then recovered equals recovered dot t. And when we now print this, you'll see that we have it the other way around. And yeah, that's how we wanted it. We have the countries here, the dates here, and these are the confirmed cases. Now, let's just check for the other two data frames as well. just to make sure I didn't make any mistakes. And then we can get to the next step. Yep, it's fine, as you can see. So let us get into the next step. So in the next step, what we're now going to do is we're going to use the data that we already have to create some new data or to calculate some new data, because we're not actually creating it. We're using the data that we have to extract some new information, because we now have the confirmed data, the deaths, and the recovered cases. And with these three values, we can calculate growth rate, we can calculate the active cases, we can calculate the death rate, we can calculate the recovery rate, and all of that. So the first thing that I want to do is I want to calculate the growth. I want to know how much more people are infected every day, because I have the confirmed cases, and I don't have any increases in infections here. I just know that on one day, for example, I have 100 cases, and the next day I have 102 cases, but I don't have a data frame that tells me, okay, this day you have 2 more cases, and also I don't have a data frame that tells me this is 2% more than yesterday. And this is what I want. So what I'm going to do now is I'm going to create first a new cases data frame, and for this I'm just going to copy the confirmed cases. So I'm going to use the copy function here. It's very important that you use the copy function and don't just say equals confirmed, because then you pass the reference, and when you change new cases, you also change confirmed. So if you want to just copy the array, always use the copy function here. Not the array, sorry, the data frame. So in this case, we have a copy, but this copy shall now be changed. So we're going to say for every day in, and now we're going to specify a range. And this range shall go from the first day that we can do a calculation for, which is the second day, because what we're going to do now is we're going to take the cases today minus the cases yesterday to see how many new cases we have. And of course, this does not work with day 0 because we cannot look at the day before that. So we're going to say from range 1 instead of 0 up until the length of the data frame, which is basically how many rows it has. And then we can say for each day, we're going to say new cases dot ilog day. So at this particular day, we have confirmed of this day minus confirmed of the day -1, which is the day before. And then we get a data frame full of the new cases. So we can go ahead and just print it. New cases dot tail, maybe the last 10 entries. And then we can see how many new cases we have. Okay, we have an error here. What is the error? Oh, of course, I forgot to use ilog, which is basically looking for the index, because of course our key is a date. We cannot just use a number, but now it works. And you can see this basically means not that in Albania we have 10 cases, but this day, on this particular day, we have 10 new cases, sorry. Basically saying that we have 10 more cases than yesterday, then we have 5 more cases than yesterday, and so on. And actually, if we want to double check that, we can just go ahead and say confirmed dot tail 10. And you can then see, hopefully, that this is actually the case. So you can see on the 13th of March, we had 33 cases in Albania. And on the 14th, we have 38, which is 5 more. And you can see, yes, in fact, on this date, we had 5 more than yesterday. Then we have 42, which is 4 more. As you can see, 4 more than yesterday. This is how we calculate the new cases. And now what we want to do is we want to calculate the growth rate. So we want to know how much percent is this? Because if a country like China has 10 more people, it's not that much of a big deal. But if a country like Switzerland or Austria or the Netherlands has 10 or 100 more cases, this is a much higher number, because we have less population here in Europe, for example, in contrast to China. So what we're going to do now is we're going to say growth rate equals confirmed dot copy. So we're going to just make another copy. The reason I make a copy is to just copy the structure, and then I change all the values. So then we say again for day in range, and we're basically doing the same thing for day in range length confirmed. but this time we're going to say growth rate dot ilog day equals, and we're going to say basically new cases of this particular day. So how many new cases do we have at this day divided by the confirmed cases yesterday. So we're looking at the number of new cases compared to the number of cases that we had yesterday to determine the growth rate in percent. And what I'm also going to do here is I'm going to multiply with 100, just because later on in the Matplotlib visualizations, I don't want to see 0.8, but I want to see 80%. So I'm going to say 100 here, times 100 here. And then we have the growth rates, and we can go ahead and print growth rate dot tail 10 to see the last 10 entries. And there you go. You can see that the case that we looked at for the 5 new cases were 15%, which means that the 5 cases were 15% of the totally infected people a day before. And you can see that this varies quite a lot. So we have 43. Of course, if a country has 1 infected person and on the next day we have, I don't know, 2 infected people, then you have a 100% growth rate, which is not really interesting because you're just dealing with 2 cases. What you can see here is not a number and infinite, which happens when up until now we had 0 cases here. And this is actually the first case. So you have basically from 0 to any number will be that number divided by 0. And it's actually not defined, but in Python, this is infinity. But you can start calculating from the next value on. So this is how you calculate the new cases and the growth rate. Now, these 2 values are definitely interesting, but what is even more interesting is how many active cases do we have? Because of course, I can talk about the growth rate, but actually, if more people are recovering than getting sick, I actually have a negative growth rate. But in this case, I would get a positive growth rate because, of course, if 2 people get sick, it's 2 more people. Even if 1,000 people recover on that day, it's still 2 plus, because I'm looking at the absolute totally confirmed cases. So they are not getting less. They're always getting more or staying the same. So we cannot decrease that number. So what we're actually interested in is we want to know how many active cases do we have and what is the overall growth rate? What is the actual growth rate of these cases? So what we're going to do now is we're going to say active cases equals, guess what, confirmed dot copy. And now we're going to say for every day in range. And this time we're going to start with 0. I'm going to explain why in a second. So we're saying from 0 to the length. We're starting with 0 because here I don't have to go 1 day back. I'm not looking at past data. I'm not looking at yesterday. I'm just looking at this particular day. And the amount of active cases in a certain day, so ilog day, is actually just the amount of confirmed cases in that day minus all the people that have died from this disease, unfortunately. So basically deaths.ilog day up until now, and also minus all the people that have recovered, fortunately, from this disease. So this is obviously true because you have all the cases that were ever confirmed, and then you just subtract all the people that have died from this disease and all the people that have recovered, because the rest of the people are people that didn't have any outcome yet. So these are the active cases, and of course right now I can also calculate the overall or the actual growth rate. And for this, again, I copy this, and here again we here again we say from range 1 to length confirmed, because here I'm looking back. So we're going to say that the overall growth rate at a certain day is based on the actual cases. So we're going to say that the active cases on that day, on that particular day, minus the cases of the active cases of the day before, day minus 1, basically, this number here divided by the number of active cases one day before. So basically, again, comparing it to the numbers of yesterday. And again, I'm going to multiply all of this by 100 so that we have the actual percentages there. And we can see that when we print that, we get, what do I want to print? Overall growth rate. And I want to print the tail of that, 10 less entries. And there you'll see that we have an error. Okay, what's the error? Did I again forget the iLog? Yes, I did. Now it should work. Yeah, there you can see, okay, it's actually not that different, but here you have now different percentages, most of the time at least, because of course, if you have cases like in China almost nobody is getting sick anymore. You have like 10 cases a day, 10 new cases a day, but at the same time, a lot of people are recovering, like 100, 200 a day or something like that. So actually you have negative growth, but if you look at the first growth rate here, you'll always have positive growth or zero growth, which is not really representative because of course numbers are technically growing in China, but actually this country is already on the way to recovery. So this is what we get here with the overall rate. We could actually look at China if we wanted. So we can particularly look at one country here. So we just say overall growth rate of China the last 10 days, and you can see it's negative. You can see that we have -8%, -10%, -11%. So basically people are recovering faster than new people are getting sick, which is a very good thing. And I think China is the only country or one of the few countries where this is the case, because in other countries, let's look at, for example, Italy or the United States, is also not beautiful to look at. These numbers are horrible, but as you can see in Italy, you have 40, 41, 18, 16, 12% of new cases every day, active new cases, not just overall confirmed new cases, but actively sick people today, which is really not a good thing. So this is how you calculate the active cases and the active actual overall growth rate. Now, before we now get into the visualizations, we want to talk about two more values here. And the first one is the death rate. The death rate is very important because it gives us some information about the lethality of the severity of the virus. And in this case, we're just going to, again, say confirmed.copy. And we want to know how much percent of the people who have been diagnosed with COVID-19 have lost their life to it, which is a very unfortunate thing. And this is one of the most important things that we need to know about the virus. How much people is it actually killing? So what we're going to do is we're going to say again, for every day in range 0 up until length confirmed. So we're starting with 0 again because we're not looking back a day. We're just looking at each individual day. And we're going to say that the death rate at a particular day for a specific country, so basically death rate ilog of this particular day, is actually the amount of people that have died from COVID-19, which is the deaths at a particular day, divided by all the people who have been diagnosed with COVID-19. So we're going to say confirmed.ilog day. This again gives us a percentage, so we're going to multiply this by 100, and this is actually the death rate. Now, the second thing that we're going to talk about is the hospitalization rate, which means how many people, how much of the infected people are actually needing a hospital. Now, of course, we're not able to just calculate this from the data here, so we're going to have to use some estimates. So we're going to say hospitalization, hard word to write, rate estimate equals, and I'm not claiming that this number is true, I'm just using it as a calculation here, but I read in an article that this number should be true, that 5% of the people infected with COVID-19 will need a hospital bed. So even if this number is not true, you can change it if you want to 2%, you can change it to 100%. Doesn't matter, but I'm going to show you how you could do some calculations with this. So we could actually say hospitalization needed equals confirmed copy. And this data frame shall have the information of how many people need a hospital bed at this particular day in a particular country. So we're going to say for day in range 0 length confirmed. We're going to say that the hospitalization needed of a particular day is actually just the amount of total, or actually not confirmed, but we need the active cases, because just because you were once diagnosed with it doesn't mean that you are still active. So of all the active cases that we have right now, 5% are going to need one. So actually the hospitalization rate estimate. As I said, this number doesn't have to be true. It's just what I read. It could be completely wrong. So you can use any number you like, but 5% is a realistic thing. Might be lower, might be higher, I don't know, but let's just work with this one here. So basically you're just multiplying 5% times the active cases. So this is important because every country has a certain amount of hospital beds. So they have a capacity for sick people. And in Italy, for example, this capacity is running short right now, especially in the northern parts of Italy. We have too many sick people and too little hospitals, too little people to take care of these people, of these sick people. So this is an important number as well. And these are the values that we're going to look at. So now we're getting to the visualization part where we put our data into graphs. So let's put a comment in here, visualization of all of this here. So the first thing we're going to visualize is just the confirmed cases for a couple of different countries. So we're going to say countries, and we're going to define a list here. You can put in all the countries you're interested in. I think most countries are in this list, if not even all of them. So I'm interested in Italy because that's a particularly hard situation right now there. I'm interested in Austria because I live in Austria. I'm interested in the US because it's one of the most important countries in the world. I'm interested in China because that's where it all came from. And let's just put India because a lot of the people watching are Indians. And also let's put France and Spain because these are also countries that have a pretty high infection. And one more, UK is also interesting because UK has also some problems right now. So we want to have a line, a graph for each of these countries. So we're going to say for country in countries, we're just going to say that we want to plot the confirmed cases of that particular country. What the hell is this? Sorry. The confirmed cases of this particular country, we're going to plot these. So we can use pandas to plot. Of course, it needs Matplotlib, but it plots directly out of pandas. So we could just pick a series or a data frame and just say plot. And then we could go ahead and say plt.show in the end. But one more thing, because like this, we're not going to see anything. Let's put a label here. So label equals the country name. And then we're going to say plt.legend so that we know which line is what. We're going to say plt legend. And the location of this legend is the upper left because there we want to have our legend. Should be fine. Okay, doesn't work. Okay, UK is not a symbol. Let's just ignore the UK for now. I don't know what the name is here. But for the rest, it works. As you can see, we have Italy, Austria, US, China, India, France, Spain. And you can see that the curve of China looks pretty different than all the other curves because China had its exponential growth time in January up until the mid of February. And then it started, the growth rate started declining, as you can see, and they're barely even getting any new cases at all. So it's almost stagnating here, which is a very good thing. If you look at countries like Italy, for example, this is still a pretty hard growth curve. It's growing very fast, actually, exponentially, and also for most of the other countries, as you can see here, Spain, France, also the US is skyrocketing right now. Austria is also on an exponential growth rate here, but it's a little bit better than most countries, or maybe just a little bit earlier. But most of these countries have some regulations now or some countermeasures to this virus. So probably they're also showing some effect. As you can see, India, which is the purple one here, is almost not having any cases at all. Might stay the same, maybe, I don't know. Might also change in the future. I hope not, but could happen. I don't know. I'm not an expert. I'm not here to analyze this politically or from a societal aspect. I'm just here to show you the math and the programming. But this is how you visualize it. And we're going to add a little bit more of a neural 9-like style here. So we're going to say axis equals plt.subplot. And we're going to set some color values here. So we're going to say axis.set face color, and this shall be just black. Then axis.figure.set face color. This should be a dark gray, which is 1, 2, 1, 2, 1, 2. And then we also have some tick parameters. Axis equals x, and the colors actually is white. So we just want to have some white ticks because we have a black or a dark background. Then we also want to have a title, set title, and the title shall be, again, come on, title shall be COVID-19 total confirmed cases by country, for example. And the color of this should be white. And then, of course, okay, the legend is already there. But I think that's actually it. This should look way better right now. Let's see. Yeah, there you go. This looks a little bit more like a neural 9 graph. Yeah, as you can see, China is quite different. We could also just remove China from the list or replace it by, let's say, Sweden. To zoom a little bit into the similar growth rates here. What we could also do is we could cut off the first couple of days because, as you can see, there's almost no growth happening until the 21st, 22nd, 23rd of February. So we could just cut off the first 30 days or something. We could do this by just saying 30 colon, which means that we start at day 30. And then you could see the growth a little bit better. Or actually, let's just cut off 35. Might be even better. There you go. Now you can see that it's really exponentially growing. So let us just visualize the growth rate in for each individual country. Now for the growth rate, we're going to do this a little bit differently because we're not plotting a simple plot, but we're plotting a bar chart. And because of that, I'm going to plot all the countries individually so that it's a little bit easier to see all the information. So let's just use 3 countries here, or maybe 4 countries, China as well. Or maybe most of you are probably not interested in Austria, so let's take Germany. So total confirmed cases, no, we want to have the confirmed cases growth rate. So we're now going to say for every country, we want to have a bar chart, but not from day 35, but from the beginning. We want to have plot.bar. And we actually don't need this here, but maybe we are going to need, actually this needs to be in the loop then, because every time we do a plt.show, we have to do the styling again. So we're going to do it like this, and we're going to say not by country, but in a specific country. So we're going to use an F string here, and we're going to enter the country name here. So I think this should work if I didn't forget something. Oh, yeah, there you go. But actually, this is not true because we're still plotting the confirmed cases. We need to plot the growth rate. That looked just too exponential. That's not true. That would be a disaster. As you can see, this is the actual confirmed cases growth rate. So here we have basically no cases. Then here we have some cases, but I guess this is a very small number in total cases. And then all of a sudden you have a growth rate of 570, almost 570% in one day, which is ridiculously high. And then you get down to 208%, which is still extremely high. Also 150, which is still extremely high. And then you get a little bit more moderate, but you still have 50% of growth every day, which is like almost doubling, or actually more than doubling um, every 2 days. And then recently you have a growth rate of 13%, 10%, 7%, which is actually quite good. So this is a little bit better. Let's look at the next country, which is Germany. There you have similar patterns where you're at a growth rate of 12. Then you go for the US. The US has a pretty high growth rate still. They are at 30%, which is very, very high. And then we have China. And China is very interesting because it starts with a pretty high growth rate, remains quite high, and then you have zero growth here, almost zero growth here, very little growth. And as we already talked about, this is the growth of the confirmed cases. So recoveries are not even in this statistic here. So actually the growth is negative, as we saw. So this is how you visualize the growth rate. So now I got back to the format of the first function of the first plot where we plot multiple graphs at once. So I'm going to change this here to total deaths because that's actually the number that's really interesting here. Who cares about people getting sick if everything's fine in the end and no one has taken any harm? But the problem with COVID-19 is that it is also lethal and it kills a lot of people. So this is something that needs to be looked at. How many people is it killing by country? And as you can see in China, there was a pretty steep curve of total deaths, but they recognized things fast and stopped the disease from spreading, and they totaled with a death count of 3,200, around 3,200, whereas Italy has already passed China in terms of deaths, even though they have not yet reached the infection level of China. I mean, percentually they did, but not totally. But the total deaths of Italy are over 5,000, going to 6,000, and this is a really problematic situation. You can also see the US and China, not China, sorry, Germany and the US are pretty low still. But we could also look at other countries like Spain, for example, which has a lot of deaths already, but also France. And there you'll see that there are also a lot of people dying. And it is growing, unfortunately, things are growing exponentially. So then again, let's look at the percentages. So we have to go back to the other format, and we're going to say dot plot dot bar. We don't need a label then. Then we're going to use again an F string here. Total deaths of the country. And we don't need a legend. There you go, this should be it. Actually, not death, sorry. Death rate by country. So we want to know how much percent of people are dying in each country. Okay, there you go. In France, you have 8% death rate, 10% death rate, like between 4 and 10% of people who are getting coronavirus in France are actually dying, which is a pretty high number. What is happening here? We have some problems. What did we do? Oh, okay, of course. Sorry. We need to show every time we plot it. So again, as you can see in, oh, okay, we started with France. Okay, that's a problem. In Italy, you can see that the death rate is actually rising, which is very concerning because actually 2% is a pretty high death rate. If you say that 2% of people getting a disease are dying from it, that is pretty high. But Italy is currently at around 9%, and it's, as you can see, the tendency is obviously rising. So the tendency is that more and more people are dying in Italy, not only in total numbers, but actually the death rate is radically increasing. Now, of course, you could say that's not the case, because what could be an explanation for that is that so many people are getting sick in Italy that the numbers are not correct anymore. So you could say that they say how many people are infected. I don't know. Let's look at the website. The website says in Italy right now we have 63,000 cases, but chances are that they have so many infections already that they cannot test fast enough. So they have so many people sick and so many people are dying, but that the rate is going up because they cannot confirm enough cases to keep this rate low. But of course, it could also just be more people dying because the healthcare system doesn't have enough capacities. So this could be another explanation for it. I'm not here to interpret these things because I'm not an expert, as I said, but the mathematics shows that the death rate of Italy is exponentially rising, or at least, okay, this doesn't have to be exponentially, it could be linear, but it's definitely rising, it's definitely growing, which is a pretty concerning thing. Also in Germany, you can see death rate is rising, but here you have to take care that this death rate is pretty low. We have a death rate of uh, these are already percentages. So it's not like this is 35%. This is 0.35%. So 0.35% of Germans are dying when getting COVID-19 right now. As you can see, tendency rising, but it's actually a pretty low number here. In Austria, it's pretty similar. Switzerland, it's a little bit higher. In the US, you can see that the death rate is decreasing. I don't know why that is. Maybe because they did more and more tests right now. Because there was a time where the US did very few tests on people, and now they're doing more tests. So maybe this is the reason why the death rate of the US is declining. This is a good thing. Then you can see China actually having a constant death rate, of course, because there were a certain amount of confirmed cases and there a certain amount of people died, and they totaled with a death rate of around, you could say, 4%, basically, which is a pretty good indication that this virus has to have a mortality rate. I think I'm just saying what I think right now. It doesn't have to be some expert knowledge here. But since there are not any new cases in China recently and people are recovering and still recovering or dying, this is a pretty solid death rate, at least for the country of China. So you can probably expect the death rate to be somewhere around 4%, maybe. I don't know. Experts say that it could be lower, which is, of course, a good thing. I hope this is true. Also, you can see in Spain, numbers are rising. Death rate is rising around 6%. And France is actually quite interesting because you have like 8%, 10%, and then it drops dramatically. And then it increases a little bit. So they have a death rate of around 4% again, which is moderate, I would say. And this is how you visualize the death rates and the actual deaths. So now we're going to experiment a little bit around with different numbers that are not to be taken too seriously. They're just some ideas, some experimentations. These are not actual numbers, but let's say we have a potential growth rate or a simulated growth rate of confirmed cases. Let's say we have 10% a day. So basically 10% more infections than yesterday. Now, what we could do is we could simulate what this would mean for the future. So how many people would be sick in 40 days, in 30 days, and so on. You can, of course, adjust this number as you want. In countries like Italy, it is somewhere around, I mean, right now it's lower, but it was somewhere around 40 to 50% a day. Now it's more like 10 to 20, but you could also use like 5% a day if you want. Just pick a number where you say, okay, if this number is the growth rate every single day, 10% more people are getting sick, what will be the result in a couple of days? So we're going to pick 10% here as the simulated growth rate, and now we're going to just append some data onto our data set that we already have. So we take the confirmed cases and we add the data to that. So we're going to first define some new dates because we need to put them into the index column. And we're going to say dates equals, there's a function here called, from Pandas called date range, which allows you to create some new date items. And you say, okay, start is, which day are we going to start? The start is actually the day, is actually yesterday because today is the 23rd. And the data set ends at the 22nd. So we're going to say, okay, 22nd of March is the last day that we used, 2020. This is the start date from this day on, or actually, sorry, not true, 23, because we want to start from the first entry that's not there. So from today, basically. So this is the start date, and now we're going to say periods equals, we want to have how many days in the future do we want to predict. Let's say we want to see 40 days into the future with this simulated growth rate. It's not the real future, it's just our future that we simulate here. And we're going to say the frequency is daily, so D. Then what we're going to do is we're going to convert this that we got right now into a series. So we're going to say pd.series of dates. And then we're going to change the format into a string. So we're going to say dates equals dates.dt.strf_time. And then we specify the string format. We want to have a month. We want to have the day. And we want to have the year, because that's the format in our data frame. If you don't know the format in the data frame, just print confirmed and you'll get it. I'm not going to do this not right now. We did it in the beginning. So these are now the indices, the new dates for our data. And now we're just going to say simulated equals confirmed.copy. So we're going to create a new data set here. And we're going to say simulated equals simulated.append, and we're going to append a data frame of the dates. So we're basically taking the confirmed cases data frame and just adding some dates at the end of it. And we can see what this looks like. Print simulated. And you should be able to see. Okay, now we have the visualization first, so let's just comment that out real quick. Or actually we just have to remove the plt.show. Or we might get an exception because of that, but that doesn't matter. So basically we're having we're having the dates here at the end, which is of course a problem. So what I forgot to do is I forgot to say index equals, what was the index? Index equals dates, sorry. We don't add the dates, but we do index equals dates, so that we just put the values that we just created into the index column. And there you go. As you can see, we have the indices right here, and we just continue from the third one up until the 1st of May, which is in the future, of course. So we're going to make some simulated predictions here. And for this, we're just going to say for every day in range of the length of confirmed, so basically the last day up until the length confirmed plus the amount of days into the future. So in this case, it's 40. And then we're going to say every day in this simulated, data frame, we're going to say for every day, the value is actually the day, the previous day, actually. So simulated day -1 times 1 plus simulated growth rate. Because of course, if I'm multiplied, I have to multiply by 1.1, not by 0.1, because then I actually only get 10%. So in this case, I increase it by 10%. There we get our simulated values, and that's actually it. Now we only have to plot this again. So this is what we would end up with for each country, you could say. So let's say future simulation for, let's say, Italy, statically in here. And then we would have to plot the simulated growth here. So simulated of Italy dot plot, and we could just make plt dot show. I hope I didn't forget anything here. Let's see. Okay, key error 60. What's the, okay. I always make the same mistakes. Always make the same mistakes. ilog. There you go. And the result is this here. Again, don't take this too seriously because, as I said, I'm not an expert here, but this would be the number after 40 days. In this case, it says it would be 2.6 million. It's mathematically true that if you grow 10% every day in 40 days, you would reach that number. But of course, you need to take into account that there is a limited population of Italy. They have 60 million people in their country. It's not really sure if it's not going to slow down if more and more people get infected, because sometimes you reach at some point you reach a limit. Also, there are countermeasures, so don't think that this is necessarily what's going to happen in Italy. But if the growth rate would be 10% every day, this would happen. We could also go with 5%, see what happens. If the cases grow 5% every day, we would end up with a value that is 417,000, a little bit better. But of course, if it's 20%, and that's not a too high number because we have countries where the growth rate is still 40% a day, we would see that this is a number that cannot actually be reached. This would be like 8 billion. As you can see, this is not realistic because at a population size of 60 million, you cannot reach more than 60 million. But this is just showing what would happen. So you could say that if you have a 20% growth rate daily in 40 days, probably all of Italy would be infected, mathematically speaking. Of course, this is probably not what's going to happen in the real world. We could also go ahead and do this for other countries, but the results wouldn't be that different. For example, if we take a country like, I don't know, let's take Austria again, because we don't have too many infected people. Let's take a growth rate of 10%. In 40 days, you would have probably also a pretty big number. You would have in 40 days 140,000. Actually, I thought it would be higher, but it's still pretty high for Austria because that's like Austria has like 8 million people in its country. So this would be a pretty high percentage here. So this is the first simulation that we did on how things could grow if we specify a specific growth rate. Now, one more thing that I want to mention here is, of course, you can go ahead and compute the actual mean growth rate, the average growth rate of a country. So you could go ahead, I'm not going to do it right now, I'm just mentioning that this is possible. You could go ahead to the growth rate, to the actual, not actual growth rate, but the confirmed cases growth rate data frame, and you could run a mean aggregate function over all the values for a country and get the mean growth rate of that country and then use this as a growth rate. But of course, this is also not really realistic because some days a country will grow 50%, 100%, 500%, as we saw. And on a lot of days, it will only grow like 10%, 5%. You could also take the median value, but still it's not realistic for a country to have the same growth rate every day. So, but if you want to do that, you could do that. That's just one thing that I wanted to mention. Now, the next thing that we're going to do is even more speculative than this one, and it has to do with the death rate. We talked about that Italy, for example, has a lot of deaths, and the death rate is rising because probably not enough people can be tested. So a lot of people will be sick without being confirmed of or diagnosed with COVID-19. So what we could do is we could get an estimate of a death rate and then calculate the probable, or estimate just the cases that we think could be the actual cases that a country has. Because of course, when people are dying of COVID-19, this is probably something that you're not going to miss, at least not often. So if 10 people die, you're probably going to recognize that 10 people died of COVID-19. Whereas if 10 people get sick, you're not necessarily going to know that they're sick. So you're definitely having more infected people than are confirmed cases, but the death number should be pretty accurate. And again, here I'm not using any number that has to be taken seriously, but what I'm going to use as a death rate here, let's say estimated death rate here, is that experts are saying that COVID-19 has probably a death rate of like 3% or 2%. So we're just going to go for 2.5% here. Actually, 0.025 would be the percentage here. So if we use this death rate of 2.5%, we could use it to calculate how many active cases, or not active cases, but confirmed cases, Italy should have in reality. So we have the total deaths right now. So let's say print deaths of Italy. And what I want is the tail, the last, let's say, okay, let's just say 5, but the default is 5. So let's just run this, and you're going to see that 5,476 people have died. So we could go ahead and say pick value 5 here. And I think this should give us the number. No, doesn't give us the number. Dot ilog 5 maybe. Oh no, I know what the problem was. Index outbound. Has to be 4. Yeah, there you go. This is the number of total deaths. So now what we could do is actually the number of deaths should be the total amount of people infected times the death rate should give us actually the amount of people who died. So this is the ideal world. If you know what the death rate is, this should be true. So you have a bunch of people that are infected times a certain death rate, and this should equal the amount of people who have died. Now, if you know how many people have died and you know the death rate, but you're not sure about the infected people, what you could do is you could just say infected people equals deaths divided by death rate. Now, of course, again, this is very speculative, but I'm just saying if the death rate really was 2.5% everywhere in the world, this should be the case. So we could just pick the deaths and divide them by the death rate, the estimated death rate, and we should get the number of estimated people that are actually infected in Italy. And this number is 219,040. Now, I don't think that this number is entirely true, because 2.5% is probably the death rate that you have if everything's working fine. This is probably how many people the virus kills if they get medical care. So because there are a lot of old people and a lot of sick people that will die of COVID-19 because of their physical state, even though they get medical care. But in a country like Italy, more people are dying because they're not getting medical care. They could survive if they would have enough healthcare capacities, but they're dying probably because, or they're dying more because they are not getting the medical care. And you can see this because in countries like Germany or Austria, you have a death rate of below 1%. And in countries like Italy, you have a death rate of, I don't know, a very high death rate. I don't know what the number was. Wasn't it something like 8 or 9%? So actually, if you would use 8% here, you would probably get the number that is that you see in the news. But of course, I could also go ahead and say in Austria, people are dying like less than 1%. So we could say, okay, 0.067, because that's, for example, the death rate in Austria. And if I use this number on Italy, which is completely unrealistic, I would get a ridiculously high number, which is not true. So I would get almost 1 million infected people in Italy, which is probably not true if I apply the death rate of another country, because in Austria right now we have enough capacities, we have a good healthcare system. In Italy, this is not the case right now. People are not getting medical care, so this number might be misleading. So this is, again, something that is to be taken with a grain of salt, but this is how you could estimate the actual amount of infected people if you know the death rate and the deaths. Now, before I end this video, I want to talk a little bit about the relevancy of everything that we just saw. Why is it important to care about COVID-19? Why is it important to analyze the numbers? And why should we care about it? Now, as I said in the beginning, I'm not an expert on economics. I'm not an expert on politics. I'm not an expert on societal issues, uh, not on biology, not on medical systems and everything like that. So I wouldn't say that I'm someone that's qualified to do any interpretations here, but I know that this situation right now, since I understand the mathematics and I analyze the numbers a little bit, is really concerning. We have very high growth rates, exponential growth rates. People are dying in Italy right now because the capacities of the healthcare system are not enough. And people compare it to China and say that it's not a problem because China had more people infected and Italy has less than China. But at the same time, the deaths in Italy are twice as much as in China because, of course, the capacities in Italy are much smaller than in China because China has like, I don't know, 1.3 billion people or something. And the problem why this is relevant is because a lot of people are not understanding the mathematics behind this. A lot of people are not really grasping the concept of exponential growth. Because, of course, if you take a simple series, mathematical series like 2 to the power of n, it is growing very slowly in the beginning. So you can say, okay, if that was the infection rate, it would be pretty slow after 10 days because you would have one infection, then two, then four, then 8, 16, 32. 64, 128, then you would have 256, 512, and so on. And you would say, okay, that's not much because you're still below 1,000. But if you go 40 days into the future, you'll see that this rate is increasing dramatically and you already reached 1 million. Then a couple of days into the future, you reach 1 billion and so on. So it's really the concept of exponential growth that's dangerous here because this disease is spreading very fast, and even though its lethality might not be the most important or the most or the highest lethality that we have in on this planet, it's still a problem that so many people are getting sick at the same time. And this is the reason why I made this video, because I want to make aware of the mathematics here. I want to show people what these numbers could lead to if people are not taking countermeasures, and how important it is to stay at home where the government tells you to stay at home, how important it is to wash your hands, and all these things, and not just think that, oh, just 1,000 people are infected in my country, who cares? Because these 1,000 people can develop into tens of thousands and hundreds of thousands in a very short period of time. So that's why I made this video, and that's why all these things are relevant. So that's it for today's video. I hope you enjoyed it. I hope this video was informative and had some programming value to you, some mathematical value to you, and maybe even some societal value to you, some human value to you. If you liked it, click the like button, share this with someone who doesn't believe in the danger of the coronavirus, and maybe share this to coders that just want to analyze stuff with data science techniques in Python. Other than that, thank you for watching. Subscribe to this channel if you want to see more. Feel free to ask questions and give feedback in the comment section down below. And see you in the next video. Bye.